Hey guys, it's Elliot Watson.
Hey guys, it's Xavier Guerra.
I'm Pablo Verdisco.
I'm Christmas anyway.
And this is a video of our physics water bottle project. So what we're going to be doing is constructing a water bottle rocket. We're going to be testing different variables including air pressure, but it's going to help us determine which affects to how high the rocket goes most.
Yeah,
So in our water bottle rocket project, we're going to have a dependent variable, which is obviously going to be how high the rocket goes, but we're going to be changing up how much pressure we add to the bottle. And then, so our hypothesis is if the more pressure we add, the higher the bottle will go. And the less pressure we have, it won't go as high. So our control variable is going to be how much water we put into the bottle. And
Great.
yeah.
Oh, didn't say that. Hi, this is our AP Physics bottle rocket. So this is what we're using as basically like a guideline for what we're going to be doing. And all these materials are, we're not going to need like spray paint and all these other things, but bottles and the X-Acto knife and super glue, those are all things that we're going to be using. So this is basically giving us like little step-by-step guidelines on how we're going to want to execute this. We're going to cut the bottom, and then we're going to get two bottles, and we're going to tape them to the top one right there. So this bottom one right here is where we're actually going to put the water, whereas the top one is just going to be the container that's going to be sort of our cone for our rocket, and that's where we're going to put the tennis ball. And the bottom right here is where we're going to put the PVC pipe, and that's where the pump is going to be applying pressure, and that's what's going to be setting up our rocket. And then we're going to be also be putting our own fins, not necessarily these, and that's what's going to be put on the side of the rocket. Yeah.
Right now, we are going over Elliot's last rocket project. We think this is a very good source because it's giving us like all the sources he used. It's giving us like how to do the project, and we think this is really good to be based on in order to start doing the project.
So the main source that we are using is this water rocket website that was produced by NASA. Here they give a picture of a demonstration of what our rocket should look like. So here is a rocket, and there's a launch tube with the plume which shoots out the water, and it shows the water inside the bottle and the pressurized air above the water. So it gives us a little description about what we should do and how we should construct a rocket.
Again, all together, please.
So right now we're cutting out our fins. So we're going to be creating our fins based on the length of the flat area of our bottle, which is 6 inches. So we're making our fins 4 inches tall. So it should be about right here on the bottom. Now we're going to start cutting. Alright, so our fin should look about like that. And I believe we're going to make 3 or 4 more. So, now we're going to be adding a tennis ball into our rocket to give it more mass. When we give it more mass, the rocket will have more momentum when in flight, and it'll be harder for it to change direction. So,
Finished product. Just a little bit more.
now we're working on balancing out the torque scale to find our mass. So
Perfect.
right now we have a 200 gram mass there on that side, and the mass of our rocket over here. So we're just getting it all fine tuned up. So trying to get to balance out. So the middle of our scale is exactly at 50 centimeters. The bottle here is at 33 centimeters. So it's about 17 centimeters away from the center. and here it's at 63 centimeters, so it's about 13 centimeters away from the center. So yeah, there it is, all balanced out. Xavier, don't touch it, you're gonna miss it.
It says 63.2. We gotta know that exact because
Six-
63 makes a big difference. Like, because if I move it to 63, it's gonna like fall like crazy.
Okay, 63.2.
63. That's 63. But if I do 63.2, it should balance out, right? Okay. A little bit more in
It's
there.
because you moved it this way, so I moved it a little this way.
Yeah, see?
So this one is exactly at 33 centimeters, and this one is at 63.2. Yeah. So there it is.
We use the torque to measure our rocket. We use, in order to do that, we use the equation dm equals dm. We placed our rocket on the 33 centimeter times, so basically the 50 meters minus the 33 meters times the mass of the actual rocket equals the other mass we used, which was 200 grams times the place, the 63.2 centimeters we placed it in. We got 17 centimeters times the mass of the rocket equals 13.2 centimeters times the other mass we used, 200 grams. We divided both sides by 17 centimeters to get the mass of our rocket, which was 155.3 grams.
Oh shit.
Here we are using tracker analysis video in order to analyze the video of the rocket launch. So as you can see here, as the frame rates play, you can see the object moving. It's already moving. It's falling down. Right there. So using this tool, we analyze the mass of the rocket. We analyze the rocket, and we use the graphs. We check the graphs of time versus displacement, the time versus velocity, acceleration, momentum, kinetic energy, and all these different components of how the rocket moves up and down.
Our hypothesis was correct. When we added more pressure to the rocket flew higher and had more velocity. Possible errors were when we recorded the video, the rocket went so high that even from the far view we couldn't really get the top of it, and we recorded a lot of the ground when we really didn't need to. Next time we'd record from a little bit farther back and get a bit different angle of the video. And a phenomenon, especially you can tell in this video with the slow-mo, when the rocket takes off, there's a trail of water that gets left behind it, and this is because the water has momentum, which is when it's launched from the rocket. It trails behind it because when the rocket has momentum, it won't be able to change direction as easy because it has some mass and velocity going in a certain direction. From this project, we learned the characteristics of how momentum works, velocity works, and a few other characteristics that we've learned in the classroom. And some advice that we have for other people is make sure you video several times and do several launches to make sure that you get enough data and good video quality.